Graphical analysis is our third and last topic. It can be a little bit of a tough one. What we're going to do here is we're going to look at ways to read graphs beyond just reading what's on this axis and what's on that axis. Graphs can tell you a lot more information than what it just first appears to do. So for example, when we look at a position versus time graph, most people can look at a graph like this without ever having taken a physics class and compare two different motions on here and get some basic answers right. Are these showing up on the video? Car A, car B. If we asked you which car went to a farther position, you would read the graph. You would see, oh, car A, it went to a higher position value. But we also can answer a question that's not directly on the graph, like which car was going faster. Most of us know this answer before ever even taking physics. Most of us would say car A is going faster. And you have an intuitive idea why. Maybe in your head you say, well, they both traveled for the same amount of time, but car A went to a farther distance or position, so it had to be going faster. That works, and that really is what you're calculating there. What you're really doing by answering that question is you're looking at the slopes of the graph. The slope of A is steeper, and the slope represents the speed. So, couple ways that you can figure that out. When you think about slope, you think about rise over run. I think one of the easiest ways to help you figure out what a certain slope or area will tell you will be to think about how you would calculate it, put in the units that you have into the equation and see if you recognize them. The rise units, that's the position, that's done in meters. The run units, those are seconds. Meters per second, I recognize that. Those are our units for speed or velocity. Therefore, I know that the slope of a position versus time graph would tell me velocity. I do the same process if I had a velocity versus time graph. If we asked you, what does the slope of this line tell you? Most people would have a harder time than answering that question here than they did here. You go through the same process though. What is slope? It's rise divided by run. Well, in this example, the rise is meters per second. Those are the units. Divided by seconds. Now be careful in this part. Don't just look at this and immediately assume that you know how the variables work out, because this is where people make mistakes. You're dividing here and you have fractions. When we divide with fractions, instead, we think of this as meters per second. You pick up the bottom fraction, you invert it or take the reciprocal and multiply. This then comes out as meters per second squared. So the slope of a velocity versus time graph comes out with these units. Those are the units of acceleration. Therefore, this slope tells me I was negatively accelerating. If I tried to do that exact same thing, exact same process, with something called an acceleration versus time graph, what does the slope of this graph tell you? Well, the rise units, meters per second squared, divided by seconds, that's like seconds over 1. You got to pick it up, invert it, multiply. Now you get meters per second cubed. We don't recognize those units, so we're going to say it doesn't tell us anything useful. If you take calculus, eventually you'll learn that this teaches you something we call a jerk. how fast an acceleration is changing. But for our purposes, we're not going to use this value. So what do we do to help ourselves figure out exactly what a slope means? Not just calculate a number, but understand what it actually represents. We look at the units for it. So we can sum this up. If we always think of our graphs as going position versus time, velocity versus time, and then acceleration versus time, kind of from simple to complicated, slope kind of carries us this way across the chart. If you're on a position time graph and you calculate the slope, what do we get? The velocity, one step over. If you're on a velocity time graph and you calculate the slope, what do you get? The acceleration. And if you're on an acceleration versus time graph and you do the slope, what do you get? You're off the chart, nothing useful. We're going to do the same type of process, also asking you about the area underneath a graph. Let's start this one with